Hello everyone, welcome to my channel. Today we are going to discuss about the stud atomic keyword that can be used to manage concurrency among shared variables. Yeah, let's dive into the program. So I have a C++ program. It's a very simple C++ program. What we have is I have a method called increment, which will increment a shared value int count every time I call the method. So I have created 5,000 threads. You might not need to create 5,000 threads. My machine is really fast, so I was not getting the expected result and I was trying with 100 or 200 threads. So you could try with smaller values. It might work for you. So yeah, let's get back to the main code. So we have a method that will be called 5,000 times because I'm, creating the thread and I'm calling the thread and putting it in a vector. And I will also join the threads after the execution. So once everything is executed, the count should be 5,000 because the increment method will be called 5,000 times. Let's try to compile this. You can use this G++ command to compile this, or I'm simply using the VS Code's. It's already set up, so I can simply run it and it will generate the exe for me. So as you can see, we get 5,000 as the output. That is expected output. But if we run this pretty fast, you could see that sometimes you are getting 4998 instead of 5,000. Why this is happening? This is happening because whatever you see in this part, this is a shared variable, right? So the critical section is not properly handled. So how do we fix this usually? Traditionally, we will have a mutex. Mutex is used to, you know, uh, work on critical sections. So usually we will handle this by adding the critical adding a mutex lock in the critical section. So already have a mutex variable here. I will use the unique lock. You can also use a unique lock guard, but I prefer to use the unique lock. I will lock and unlock the critical section. So this should ideally solve the problem, right? Let's run that again. It's taking a while. Okay, so if you so now if you run this consistently, you will not get a different output. It will always be 5,000 because the code is under critical section. So there is another alternative to this. Let's comment the mutex part and let's introduce std atomic int here. So what I'm doing to do is I'm going to create one more shared variable, which is an std. We usually say stud atomic int, and let's name it as atomic count. So let's do the same thing here, and let's see out the atomic count also. So as you can see, we have completely removed the mutex from the critical section. Let's run this again. Okay, so now if we run this continuously, what do you see? So the count is being affected by the threads, but the atomic count always remains the same. And we are not using the mutex. So this is an alternative way to use, if you only have a smaller number of shared variables or something, you can use the stud atomic. There are a lot of atomic other variables available. They have the atomic bool, atomic char, atomic, double and everything. I don't know if they have double, but yeah. So this is a good thing to use. Another thing that you need to make sure this will not work if you actually give a count equal to, sorry, because not every operators are being supported by the atomic keyword. So you need to make sure that only supported operators are used. See, now the atomic count is also being affected. So it will only work for certain operators. You can actually check the CPP reference to get a more idea about it. I hope this helps. Thank you for watching. I'll put the links in the description so that you can have a look at the code. Thank you for watching.